Artificial intelligence, commonly known as AI. What is artificial intelligence? Artificial intelligence may be defined as the branch of computer science that is concerned with the automation of intelligent behavior. It is also making the computers that perform the task that a normal human being works. These tasks include thinking, learning, reasoning, decision making, and problem solving. In other words, AI can also be described as making the computers think like humans, automating human thinking activities, creating machines that act intelligently, or studying human mental abilities using computer models. It is closely related to problem solving and computer science. It tries to understand how humans solve problems and then replicate that behavior using algorithms and problems. The next one is we will see where the areas of studies that AI is implemented. In general, AI is an interdisciplinary field. That is, it acts in computer science engineering that provides algorithms and programs. It is also applied in psychology that explains about learning, memory, and behavior. It is also applied in philosophy that contributes logic and reasoning. The main part of AI is linguistics that helps in understanding language. The biology and neurology comes into field that studies about the brain and the learning. It uses engineering to be applied for real-time systems. It does also use mathematics to generate statistics and models. So, the combination of many disciplines makes AI more successful. What is intelligence? In general, there is no single definition of intelligence. Some of the elements of intelligence include understanding, reasoning, learning, problem solving, generalization, and common sense. It also focuses on intelligent behavior rather than fully copying human intelligence. The physical symbol of system hypothesis proposed by Newell and Simon states that a system that can manipulate symbols has the necessary and sufficient capability for intelligent action. Computers are physical symbol systems because they manipulate symbols using rules. If this hypothesis is true, then it is possible to program computers to act intelligently, which is one of the main goals of AI. One of the feature of AI is Turing test, which was proposed by Alan Turing, that is used to test machine intelligence. In this test, a human asks questions to a human and a computer, and if the computer cannot distinguish between them, the computer is considered as intelligent. However, passing the Turing test does not always guarantee true intelligence. More than Turing test, some of the features has ELIZA program, the Chinese room problem also supports AI programs. The ELIZA was an early AI program that simulated conversation. It worked using simple if-then rules and pattern matching. Although ELIZA appeared intelligent, it did not understand meaning, only sentence structure. This shows that a program can appear intelligent without real understanding. The another problem is Chinese room problem, where the computer manipulates symbols based on the rules, but it does not understand their meaning. Just like a person following the instructions in a language, they do not understand. Computers process the symbols without knowing what they mean. This raises to an important question, where can intelligence exist without understanding? So, we can come to the conclusion, that is, if there is strong implementation of AI and if there is weak implementation of AI. The strong AI aims to create missions that truly understand and thinks, where the weak AI focuses on the missions that act intelligently without real understanding. Most of the present day AI systems fall under weak AI. Okay. So, what does AI do? AI solves problems by representing the knowledge, applying the reasoning. It is used in areas such as diagnosis, planning and decision making, learning, recognition and perception, natural language understanding, etc. These problems often require expert human knowledge. Okay, so before getting into that, we need to know what is knowledge representation. How we represent knowledge is very important in AI. Consider the multi-layered chessboard. How can you place dominoes on the multi-layered chessboard so that all squares are covered? Or else consider the game of tic-tac-toe where we could store each board configuration, the best move to take. This would require 3 power 9 different board configurations. Which approach is more efficient? So, instead of storing all these possible answers, the AI systems use rules, heuristics, reasoning techniques. This makes the problem solving more efficient. So, how do we represent AI techniques? Some of the common AI representational techniques are predicate logic or predicate calculus, where the items are known and it is called as predicates, and we are using some rules for reasoning. There are production systems where the knowledge is represented as if-then rules and uses forward or backward chaining to reason. One of the representational technique is graph theory, where the knowledge is stored as nodes and the links in a graph. The search in the graph has to be made to obtain a solution. The semantic structures stores knowledge as categories, instances and their attributes. The next one is statistical approaches, where it is primarily added to one of the above techniques to portray uncertainty. Each technique is based on the problem type. What are the problem areas of AI? There are some problem areas where it has to be addressed. That is diagnosis, natural language processing, planning or design and decision making, game playing, automated theorem proving, robotics, ontologies, agents and communication. To conclude, artificial intelligence is a powerful field that aims to simulate intelligent behavior using computers. Understanding its foundations helps us design better intelligent systems. Thank you for watching this video.